Okay, so let's solve these questions. So the first ones are easy, but if you want, I'm going to go through every single one, if you have some calculation things, but I doubt it, but like, yeah. So 12 times minus 5, that will be minus 60. This times this will be plus 36i. This times this will be minus 6 times 7 will be 42. Minus and minus will be plus. 6 and 9 will be 53, and I. And yeah, just simplify this with this, this with this. Okay, my headphones failed me, the battery finished. Anyways, so minus 2, 102, plus 6 and 3 will be 9. This is going to be 8. So this will be the answer. Next one is this with this, so minus 24. And this with this. So minus and minus will be, minus and plus will be minus. 3 and 3 will be 9i. This will be minus 40i. This will be minus 5 times this will be 15i squared. And I squared is minus 1, so it will be plus. This with this, this with this. This will be minus 9, minus 49i. And we're done. Next one. X squared plus 8x plus 25 equals 0. So basically just do the normal quadratic formula. So minus 8 plus or minus square root of 64 minus 4ac. A is 1, so I'm going to ignore it in just a number, because times 1 is just the number, over 2a. X equals minus 8 plus or minus square root of 64 minus 4 times this is 100. So this will be minus 36. So minus 36 over 2. This is going to be minus 8 plus or minus. This is nothing but square root of 36 times square root of minus 1. Because if you multiply them, it will be square root of minus 36. This is 6 and this is I. So just 6i over 2. It will be minus 4 plus or minus 3i. And so the roots are minus 4 plus 3i and minus 4 minus 3i. Now moving on. So we're going to do this. The conjugate is going to be just flipping the sign of the one with the complex. So if you had something like z equals to 12, or I can switch the numbers if you want, minus 5i minus 12, it will be plus 5i minus 12 for the conjugate. Anyways, so yeah, this is the conjugate, the modulus of z, not the conjugate, just z. It will be 5 squared, square root of 5 squared plus 12 squared. I ignored the negatives because squaring removes all negatives, so I'll just do it easier for me. So this will be 25 plus 144, it will be 169, so you get 13. Aslan it's 5, 12, 13, so that's how I knew. Z with its conjugate, so we have this with the normal z. Anything and its conjugate will always be a squared plus b squared, where this is a, this is b, and the square, again, you ignore the negatives, you can, because minus with a square becomes 1, so useless, or loses its power, not necessarily useless, but loses its power. So 25 plus 144, so 169. And to confirm that, if you want to multiply minus 5 times minus 5 will be 25. This with this, this with this. These will cancel, by the way, because minus and plus will be minus, minus and minus will be plus, and they have the same value, so they'll cancel. This with this will be minus, 12, 12, 144. I squared will be plus, and this is how you actually get 169 again. Moving on. Next one will be this and this. You want to divide them. So it'll be minus 6 plus 5i over 4 plus 3i. And then just multiply by the conjugate, so 4 minus 3i over 4 minus 3i equals, and this is where you distribute, I'm going to do it here. So minus 6 and 4, will be minus 24. This with this will be minus 18i, plus 18 actually, plus 18i, plus 20i, and minus 15, plus because it's I squared, over 4 squared will be 16, plus 3 squared will be 9, so it'll be 25. How did I do that? When you multiply two conjugates, you do a squared plus b squared. So you get 25 here. This with this will give you minus 9. This with this will give you 38. Yeah, I reached the limit. 38. I over 25. So it'll be minus 9 over 25 and this is so annoying. And 38. Let me double check. I don't know. It's 19 and 2. So you can't simplify, yeah. 38 over 25. And yeah, if I didn't do a mistake, that should be the answer. But the whole idea is, I'm doing them quickly just to show you the way. It doesn't have to be correct, but I always aim to double check, so to make sure it's correct. For this one, you just equate, what do you call it? What do they want? Where A is the real number, Z equals to W, so the real equals the real, imaginary equals imaginary. And what do they want? The value of X. So this is real, and this is real, this is imaginary, this is imaginary. So 4 equals minus 3x plus 10. To be honest, I suspect that there's something wrong because it's AI and here's it's minus AI, and these cannot be equal because they're definitely different. Minus AI is not equal to AI. Probably the only value is when A is 0, where the entire term is non-existent. So they'll be equal technically, but yeah, odd. I'm just gonna assume that A is a magical number somehow, where A is a real number. It could be anything, could be 0. Anyways, so 4 equals minus 3x plus 10, so it'll be x equals, take to the other side, minus 6. Minus 6 over minus 3, it'll be 2. Double check, yeah. So x is 2. Now the next one, this has a little thing, so let me show you. So I equals root minus 1. I squared is the square of that, so now we can save it. It becomes minus 1. Now the I cubed is I squared times I. Keep I to be I. Usually think of I as like an atom that has electrons and neutrons and protons. You can't stop there. You don't have to keep digging deeper. You can just say the subatomic particles are there and stop. So same thing here. So I squared will be minus 1, so you can have a minus here. And this will be I squared and I squared. I squared is minus 1 will be 1. And that's it. These are all you need. So the idea is that if you have a multiple of this, a multiple of this, or a multiple of this, you're gonna get these. And by the way, from this you can go to this, just like how I did it right here. You can go there. So they're multiples. So this is first of all, let me go here. Is this a multiple of 4? Yes, I can show you by taking out. Can I take out a 4? If you can do that, it's a multiple. So take out a 4, you'll be 2n plus 1. Is it a called? Can you divide by 4? Divisible by 4? Does it have 4 as a factor? Yes, it does. So because of that, it follows under this. So the final answer is what? 1. No matter how big this, no matter how huge the number here is, or the entire thing is, it's divisible by 4, therefore it's 1. So the answer is immediately 1. So let's look for the ones. So this is correct. This is definitely wrong. This is divisible by 4, therefore correct. This is tricky. Minus 1 to the 2n. Try doing something here. It's minus 1 to the 2 times n. Square this. Do the square. Apply the square. You're gonna get 1 to the n. 1 to the n is 1, and so we're getting the same answer here. Here it's not confirmed that it is divisible by 4, so we cannot confirm, so it's wrong. Same thing here, it's not divisible by 4, so the only correct ones are the ones I circled, and this is included, by the way. So yeah. So the next one will be 3. What's the value of? For this one, I just save my time by derivating real, subtraction of z minus w, real. So I save my time by just looking at the reals. So 2 minus 5 would be 7. 2 plus 5. Done. Imaginary, I only look at the imaginary. So minus 5i plus minus I. Plus minus I. So I wanted to remove the plus because it's useless here. So minus 6i. And yeah. Next one will be just minus 3z plus 4w. I save my life by just looking if I have anything that cancels. So they want real, so I only look at the real. Here the real is 0. Here this is the real. 0 times any number is 0, so I can completely ignore this term. Plus, not minus, just double checking it's plus. Yeah, it's plus. So plus 4, just multiply 4 by the real, so it'll be 4, or this will be actually like this whole thing would be 4 times minus 2, that will be 8, minus 8. So that's the final answer, because we're talking about real only. If they didn't say real, we're gonna have to do the entire calculation, but otherwise no. Imaginary of z times w, I only look at what makes it imaginary, because this is not some function, like for example, it's just telling you, just a mathematical way of saying I want imaginary values only, tell me the imaginary values, filtering basically. So this and this makes an imaginary, this and this makes an imaginary, this and this makes a real, this and this makes a real, so I ignore. Minus 4 and minus 3, it will be plus 12i. This and this will be plus 30i, so it will be plus I figured it. Anyways, plus 42i. And yeah, oh my god, without music it's a bit weird. Anyways, the headphone just finished batteries. So yeah, we're looking here for roots, so we're gonna do x squared plus 2x plus 10 equals to 0, and just solve. So x equals minus 2 plus or minus the square root of 4 minus 4 into AC. A is 1, so I'm going to ignore it, so 10 over 2. Minus 2 plus or minus, here it's 4 minus 40, so minus 36. Again, reach the limit. Minus 36. So here will be minus 36 over 2. This will be minus 2 plus or minus. This will be nothing but 6i, just like how I showed you in the upper parts. So 6i over 2, so it will be minus 1 plus or minus 3i. So minus 1 minus 3i and minus 1 plus 3i, and only those in that order. Yeah. So minus 1 minus 3i, that's right. Wrong, wrong. What does it say? We want minus 1, it has minus 1 and 3i. This is right. Does it have minus 1? No, it doesn't have minus 1. It must have minus 1. So these are wrong. So the only ones that are right are 2 and 6. Moving on, 8. What do you want? Conjugates. This and this are not conjugates, because one is real, one is imaginary, so definitely wrong. Here there's a missing term. Where's the I? They're different. Here minus 5, that's fine. 6i and minus 6i, they swap terms at the complex, which is right, because they look something like this, by the way. Minus 5 and 6, so minus 5 and 6, so something like this, and then minus 5 and minus 6 will be like this. These are complex. These are complex. No. But yeah, you get the idea, like they're opposites kind of thing. Anyways, minus 4i and 4i, these are complex. These are not complex because they switched the real, so it's just these two. 3, not the 4, not the whole thing, just 3. 3 and 5. So what's the modulus of this? The modulus of this would be the square root of 8 squared plus 6 squared. I'm ignoring the minus again because the square removes the minus. So square root of 64 plus 36 will be 10. It's a 3, 4, 5 triangular. You can see that. So another way to see it. So I'm gonna rearrange this. So minus 9 plus root 3i over 2 minus root 3i, because they want to divide. So just multiply by the conjugate. So 2 plus root 3i over 2 plus root 3i equals, down is just going to be a squared, so 4 plus b squared will be 3, so 7 down. Up will be minus 9 times this will be minus 18. This and this will be minus 9 root 3i. I think I'm going to be out of space again, so I'm just going to move. And then minus 3 root 3i with 2, it's going to be plus 2 root 3i. And this is going to be plus, I think minus, yeah, because I can write plus for now. Root this and this will be 3i squared, so this is going to be minus 1, so minus. So simplifying, minus 18 minus 3 will be minus 21. This and this will be minus 7 root 3i over 7, so this will be minus 3 minus 1. I can ignore the 1. 3i. They want the value of a, so it's just minus 3. next ones. So they want the polar form of this. So a good question. So we want for sure, by the way, if you think of it in terms of like the unit circle, let me get a better drawing for you. In terms of the unit circle, trying my best to draw a circle. So in the terms of the unit circle, you're gonna have I here, the imaginary numbers, and here the real numbers. Here you're gonna have the i's, you're gonna have the real numbers. So with an I, it's gonna be the y, and this is gonna be the x, right? And x, we used to say it's for the cosine, and the y for the sine. It's the same thing here. You wanna have the sine with the complex. So we don't want the cosine here, we want the sine. And here we don't want the sine, we want the cosine. So let's look for a way to flip them. If we need to flip both of them, then it's easy. Use the complements. So cosine of 30, don't mind me if I distribute this, plus 20 sine 30 I. And yeah, we're basically done. We can do cis. So 20 cis 30. The modulus, so 20, and times e to the angle, which is this in radians is going to be the angle 30, is going to be pi over 6. So pi over 6 I, and that will be the magic here. For this one, they want the polar of z and w. So find the modulus. This is going to be 100 plus 300, because it's going to be root 3, so, and times 100, 10 squared, root 3 squared, so it's going to be 300. So you're going to get here 20, and here you're going to get, you need the argument, by the way, you need the angle. So the angle of z is going to be tan inverse of 10 root 3 over 10, which is root 3. 10 and 10 cancel. This is basically, I believe, 60. Can double check. So tan root 3, tan inverse root 3, so 60. 60 in radians is pi over 3. Again, out of space. Pi over 3. So its polar is going to be immediately 20 modulus to the pi over 3 I. And for this one, w is going to be, the modulus is going to be square root of 2, because it's what? 1 squared plus 1 squared, that's 2. Root of that will be root 2. And now we need the argument of w. It's going to be tan inverse blah blah. I'm just going to jump right into it. Tan inverse of minus 1 over 1, that will be minus 1. For the ones, whenever you get tan inverse of 1, it's 45. We have a minus, so minus 45. Double checking, just to confirm. You can do it in the calculator, but just to double check, since sometimes you need to add a number. Otherwise, the minus 45 is going to be wrong, because the calculator only gives you first and fourth quadrant. So 1 and minus I, so it's going to be here, so minus 45, I was right. And here you're going to have, for the next one, this is z. For w, it's going to be the modulus, so square root of 2 e to the angle, so minus, by the way, this is minus pi over 4, so minus pi over 4 I. And that's it. The last one, z over w. I'm not gonna bother doing this. I can actually I can do 20 over root 2, which is 20 root 2 over 2, which is 10 root 2, times e to the, you see, when you divide these e to the blah 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 blah, you can take them together but subtract them. It's a power rule kind of thing, you know. E to the 2 over e to the 3, you say is 1 over e, but how did you know that? It's e to the 2 minus e to the 3, which is e to the minus 1, which is 1 over e. So you can do that here. Let me just clean it quickly. So e to the pi over 3 minus, so plus pi over 4 I. And that will be pi over 3 plus pi over 4, 7 pi over 12. Oh, they wanted ZW, I didn't see that, but yeah. Anyways, I can do it later. After this, I'm done. So 7 over 12 pi I. But the other one's super easy, you just multiply them. So it's going to be 20 root 2. ZW is going to be 20 root 2. You can see how I'm multiplying them. Times this minus this. You're going to get pi over 12 I. And that's it. So we're done. Now we need the polar. Okay, this is going to erase everything. So I'm just going to do this. Okay, so we need what? Polar form of z. So it's going to be, we need the modulus again, so the modulus is going to be what? Root 2. Here the argument is going to be what? Of z. It's going to be actually the same thing, minus 1 over 1, so 45. It's 1 minus 1. So 1 minus 1, so it's going to be minus 45. And so it's minus pi over 4. And so z is, again, they're repeating it again, same one, e to the minus pi over 4i. And z, actually, let's just, actually we don't need it. We know it's root 2, we know this, we know that. So we can do this instantly. It'll be this to the 6 times cis 6 times the angle. So it's going to be, we said root 2. Root 2 to the 6, I can make it root 2 to the, so square that will be 2 to the 3, which is 8. Cis, we said minus 45 times 6 is going to be minus 270. Minus 270 is down here. Minus 270. No, sorry. This is minus, so minus 270. This is 90. You can see it's 90. So I can replace this by 90 just to make my calculations easier. So 8 cosine 90 plus 8 sine 90i. This is going to be what? It's going to be, with cosine it's going to be 0, so it's going to be, this is going to be 1, so 8i. This one is the last part. It's the fourth. I know the phrasing here is super weird. I was personally on like weird in the work. What the hell are they saying? Find the fourth root. So when you do the fourth root, you do to the fourth root of z. You have 4 of them. So the fourth roots. It sounds like a rap or a poem. Anyways, so the trimes. Express your blah blah. So z to the 1 over 4 is going to be this 1 over 4 cis the angle plus 2k pi or 2 pi k over what are you doing, which power? So we're doing over 4 or to the 4th root, so we do by 4 and then just apply it. K is going to be 0, or the number of k's is going to be the number of roots, and you start from 0. So what number will you stop at? 3. 0, 1, 2, 3. Are these 4 roots? They are. So we're done. So just substitute. So what's this? The modulus to the 1 over 4. So the modulus is going to be 81. To the 1 over 4 is going to be 4th root. 3 times 3 times 3 times 3 is, 3 times 3 is 9. 3 times 3 is 9, 9 and 9, 81. So this is 3. So 3 cis. First one's going to be 0 times this, 0, this over 4. So what's the angle first of all? It's minus 81i, so it's directed down here. Minus 81i. So it has an angle of minus 90. So minus 90 over 4, that's the first root. So we can simplify. So minus 90, 45, 12, so 3 cis 12.5 minus 12.5. Because 45, yeah, 45 over 2, so 25.5. This makes 40. Oh my god, I should have just. Yeah, 22.5. I knew something. I kept saying the wrong things. But yeah. So, anyways, this is the first one. The second one will be the same way, just cis minus 90 plus 2 pi. So, plus, since I'm working with pi's actually, this is pi over 2, minus pi over 2. So minus pi over 2 plus this is going to be 3 pi over 2, 270 basically, over 4. This is going to be over 8 basically, over 8. And we're done. So this is the first one, second one. This is the first one. And the next one is just same thing, 3 cis we went just to make our life easier, because it repeats, we just keep adding how much did we move. This is, by the way, what this is, in fact, minus pi over 4 over this minus pi over 8. So we went by a pi over 2. So just go by another pi over 2, or in other words 4 pi over 8. So 4 pi over 8 is going to be 7 pi over 8, and here is going to be 3 cis. The other one is going to be 3 cis, another 4 pi over 8, so 11 pi over 8. Yeah, 11 pi over 8, yeah. You can try yourself. 3 times this will be 6. 6 pi with this, it's going to be so annoying. Anyways, it's right. I can confirm 100%. So yeah, that's it pretty much.
Alright guys, let's move to the core grid of section 10.2. So let's start with number 1. Which of the following is true about the complex number 3 minus radical 3i? Select all that apply and enter the labels in the same order as they appear. So we have 5 options, and I'll choose which is the correct polar form and which is the correct trigonometric form. So I'll give you guys a few seconds and then we'll check. Alright, let's check. So obviously with any complex number we have to start by getting the magnitude. So the absolute value of z, which is 3 squared plus negative radical 3 squared, all of that taken under the square root. So we get 2 radical 3 as the magnitude, and if we get the argument of z. Now what is the argument of z? It is basically tan inverse of b over a, where b is the coordinate is the coefficient of the I, so it's negative radical 3 over a, which is the real part, 3, giving us negative pi over 6. Now a note to be careful of is, if the real part is negative, we have to add 180 or pi if we're dealing in radians. So if we think about the trigonometric form, which is the easiest one, it is z, let me just write the general formula, z equals the magnitude of z, cis, which is cosine I sine the argument, arg of z. Using this formula we have created, the trigonometric form is 2 radical 3, which is the magnitude, cis or cosine, and the angle is minus pi over 6, plus I, because ci, and then sine, minus pi over 6. Right? So as you can clearly see, it is part 5 or option 5. Now so polar form. The polar form is simply z is equal to the absolute the magnitude of the complex number, which is 2 radical 3, and then we take e to the power of the argument times I. So the argument in this case is minus pi over 6 times I, which is very clearly option 2. So our answers is options 2 and 5. Give you guys a few seconds and then let's move on. Alright. Number 2. Which of the following is true about the complex number z equals 2 sine 60 plus I sine 60? It's very similar to the last one, so I'll give you guys a few seconds. Alright, let's do this. But you might be thinking, z equals 2 into sine 60 plus I sine 60 doesn't look familiar. So first you have to get into the form x plus yi. So let's simplify. It's z equals 2 into sine 60 is root 3 over 2 plus I into root 3 over 2. The 2 cancels, so we get radical 3 plus radical 3i. Now this is a form we all understand. So now you can find the modulus of z, which in this case is radical of 6, and you can find the argument of z, which is tan inverse of radical 3 over radical 3 tan inverse of 1, which is pi over 4. So immediately we can get the polar form, which is z is equal to the modulus radical 6 into e to the power of I times pi over 4. So that's option 1. And the trigonometric form is simply z is equal to radical 6 cis pi over 4. I'm just going to call it cis because we all know cis is cosine I sine, which is very simply 3. So our answer here is, let me just write it in box, 1, 3. Give you guys a few seconds and then let's move on. Alright, let's move on. Number 3. Consider z equals 3 into cosine 265 plus I sine 65 and w equals 7 into cosine minus 40 and I sine minus 40. If z times w is a cis theta, where a is a whole number and theta is between 0 and 360, what is a plus theta? Give you guys a few seconds and then let's check. Alright, let's check it. So the rule says that let's just make it generalized and then let's work on it. If z is a cis, let's call this alpha, and w is b cis, let's call this angle gamma. Z times w, I'll tell you both formulas so we don't have to go over it for 4. Z times w is simply a times b cis alpha plus beta. The proof is not required. And z over w is simply a over b cis, pretty logical, or sorry, a plus gamma, I'm sorry about that, whatever, it does make a difference, a minus gamma. So using this equation we can easily see that zw should be 3 times 7, 21, cis 265 plus minus 40, which is 225 degrees, but this is not what they want. They want alpha plus theta. So alpha plus a plus theta is 21 plus 225, which is 246. So this is what we will put in the computer when they ask for it. Alright, I'll give you guys a few seconds and then let's move on. Alright. Number 4 is basically they give you z and they give you w. They just want z over w and they want a plus theta. Few seconds and then let's check. Alright. Z over w is simply 20 over 4, 5 cis. Now as we should remember, I said that if it is division, we have to subtract the angles. So it's 120 minus 75, which is 45 degrees. And when they want a plus theta, it is very simply 5 plus 45, which is 50. So 50 is the answer for the question. So far it's very simple. Number 5. Given that z is equal to 3 into cosine 18 plus I sine 18, if z to the power of 5 is ki, what is k? Give you guys a few seconds, and as a reminder I'll just tell you that z to the power of n is basically the modulus of z to that power into cis n times theta. From that you guys should figure it out. So z is equal to, alright, let's check. So I said the modulus of z to the power of n, so 3 to the power of 5 into cosine 5 times 18, which is 90 degrees, plus I sine 90 degrees. 3 to the power of 5 is 243, and cosine 90, as we should know, is 0 plus I. When we distribute, we get that 243 times 0 is obviously 0, so it is just 243i. So k is 243. Let me just write this down. K is 243. Alright, let's move on to section 10.3, the first basic question. Give you guys a few seconds and then we'll discuss on how to find the locus of p of z if z is x plus yi and the argument of z plus 1 minus I is pi over 4. Alright. Alright, so we have defined z to be x plus yi. So argument of that is basically, let's just first get what is z plus 1 minus I. It's x plus yi plus 1 minus I. If we put the plus 1 minus I, if we put the like terms together, the real and imaginary, we get x plus 1, all that, plus y minus 1 I just took the I out. Now this will help us figure out the argument. The argument is tan inverse of, let's just call this A and let's call this B. So it's B over A. So it is tan inverse of y minus 1 over x plus 1, all of that is equal to pi over 4. If I apply tan to both sides, I get y minus 1 over x plus 1 is equal to 1, because tan pi over 4 is 1. Here I immediately find out the conclusion that x cannot equal minus 1 because it makes my denominator 0, and obviously it's not possible. We cannot make the denominator 0. Cross multiplying, we get y minus 1 is equal to x plus 1, where we simply get y is equal to x plus 2. So our locus is the straight line with equation y equals x plus 2 excluding the point x equals minus 1, or x excluding the point minus 1 comma 1, because that is the point that makes our equation not work, because tan inverse of y minus 1 over x plus 1 has to equal pi over 4. So it's a straight line with equation y equals x plus 2 excluding the point minus 1 comma 1. Alright, give you guys a few seconds and then let's move on. Alright, let's move on. Question 2. Find the locus of p of x comma y if z equals x plus yi and z plus I over z minus 1 is real. Give you guys a few seconds and then let's find out how to solve this. Alright, let's check. Let me just draw a line here so I get space to solve. So I'm just gonna straight away find what is z plus I, which is simply x plus y plus 1, all of that into I over. Actually, let me just go into the live board app so I actually get lots of space. So let's just go over into the z plus I over z minus 1. Let's just make a bunch of pages. So z plus I over z minus z minus 1 has to be real. We'll get to more on to what that means in a few seconds. Alright, so it is x plus yi plus I. I'm going to keep this expanded because it makes it easier to visualize what we're dealing with. And x minus 1 plus yi into. Now let's just multiply by the conjugate of the denominator. So x minus 1, all of that, minus yi. Let's just draw parenthesis here so that it's easier on us. Into x minus 1 minus yi. Now let us begin the long process of simplifying. So let's work with the denominator first, which is very simple. It's x minus 1, all of it squared, minus yi squared, yi, all of that squared, because a plus b into a minus b is very simply a squared minus b squared. Now if we find at the top, we get x squared, x into minus x minus xyi plus xyi minus yi minus y squared I squared plus xi minus I minus y squared I squared. No, sorry about that. It is not minus y squared I squared, it is minus yi squared. pretty complicated. Let's see what we can cancel. Minus, okay, let's just do it in a different color so it's easily figure out. This cancels. Is there anything else that cancels? X1 minus x. As of now, nothing cancels. Let's figure out what we're dealing with. If we simplify, if we separate the real values and the imaginary values, so we can clearly see that the I squared is minus 1, so this cancels and this becomes plus y. I squared is obviously a minus 1, so this cancels, this becomes plus y. And now we can finally separate. Let's make this again black. So we get x squared minus x plus y squared plus y, all of that over x minus 1 squared minus y I, all of that squared, plus minus y plus x minus 1 into I, all of that obviously, x minus 1 squared minus y I squared, right? Now this is our real part, or A, and this is our imaginary part, B. They said it is real, so very clearly this has to be 0. So let us show that this equals 0. Let's go to page 4. Minus y plus x minus 1 equals, okay, let's use blue color. Minus y plus x minus 1 over x minus 1 squared minus y I, all of that squared, equals 0. Cross multiplying, this whole thing cancels, so you get that minus y plus x minus 1 equals 0. So when we distribute, we should get that minus y equals minus x plus 1, getting the minus there, y equals x minus 1. But we seem to have forgotten a thing. What is that thing we've forgotten? When we say that this equals 0, so let me just erase this and re-put this. We seem to have forgotten a thing here. X minus 1, all of that squared, minus y I squared plus y squared. Let's just simplify that right now. There is the point that makes our denominator 0. That is very clearly 1, 0. So if x is 1, that is 1 minus 1 squared, which is 0, plus 0 squared, our denominator is 0, and this doesn't work. So what is the answer is, oh, sorry about that, locus is the straight line with equation or EQ y is equal to x minus 1 excluding the point excluding the point 1, 0. So basically we have to show which straight line fulfills our condition that which one was it, sorry, z plus I over z minus 1 has only a real part, that means the imaginary part is 0, and we have to be able to show which point does not work because it makes the denominator 0, which gives us an undefined answer. Give you guys a few seconds to check, and then let's move on to number 3. Alright, let's move on to number 3. Let's get rid of this. Number 3. Form a quadratic equation whose roots are 3 plus 7i and 4 minus I. This is a simple question. I'll give you guys a few seconds. And just to remind you, a quadratic equation can equal x squared minus sx plus p, which is equal to 0. This is an easy hint. And let's see. Alright, let's check. So very obviously you guys should have figured out that S stands for sum and P is product. So we find the sum, 3 plus 7i, sorry, let's just reset that, 3 plus 7i, all of that, plus 4 minus I, giving us 7 plus 6i, so that's our sum. And we have to get the product as well, so it's 3 plus 7i into 4 minus I, giving us, so let's see, 12 minus 3i plus 28i minus 7i squared plus 7, giving us, because I squared is minus 1, 19 plus 25i. Give you guys a few seconds to keep up and then let's move on. So our quadratic equation, whose roots are 3 plus 7i and 4 minus I, is x squared minus the sum, which was 7 plus 6i, x, plus our product, which was 19 plus 25i, equals 0. So the roots of this quadratic equation are 3 plus 7i and 4 minus I. Give you guys a few seconds to check and let's go to number 4. Alright, let's move on to number 4. Solve 4 plus I into z plus 6i equals 5 plus 8i. So you have to solve for z. Give you guys a few seconds and then let's check. Alright, let's check. So we take the 6i to the other side. So 4 plus I into z is equal to 5 plus 2i. It's very logically z is 5 plus 2i over 4 plus I. Multiply up and down by the conjugate, 4 minus I, 4 minus I. Our denominator is the a squared minus b squared, which is 17, because 16 plus 1, 17. 5 into 4, 20, minus 5i plus 8i minus 2i squared plus 2. So that gives us 22 over 17 plus 3 over 17i. So z is equal to 22 over 17 plus 3 over 17i. Give us a few seconds and then let's move on to number 5. Alright. Solve z squared plus 2iz minus 1 minus half I equals 0. Give you guys a few seconds and then let's move on. Let's check. Alright, let's go to the live board because you might need a little space here. So let's go to page 1. And the equation was z squared plus 2iz minus 1 minus half I. Okay. Plus 2iz minus 1 minus half I. Minus 1 minus half I is equal to 0. Let's just quickly, let me just fix this plus. It's kind of annoying. Right, so a is 1, obviously, a, b is 2i, and c is minus 1 minus half I, anything without the z. So whenever you want to find the roots of the quadratic equation, you have to use the quadratic formula, which starts by finding the determinant or delta, which is b squared minus 4ac. b squared being 2i, all of it squared, minus 4 into 1, because that's a, into minus 1 minus half I. 2i squared is 4i squared minus 4 plus 4 plus 2i, that cancels, giving us the determinant being 2i. Okay, but we have to find what are our x and y, because as we should define, z is a complex number such that it is x plus yi. So we say, no, let's actually not call it z. Let's call it w, because z might be confusing. So we say let w equal x plus yi such that, this is all our condition. We're just making assumptions here to help us solve the question in an easier manner. such that w squared is equal to delta. Okay, so we get that x plus yi all of it squared is equal to 2i. Right, so there was also this rule in the book that had mentioned that x squared, where x and yi, we're getting it from the w here, x squared minus y squared has to equal the real part of delta. Now delta is 2i, which can also be written as 0 plus 2i. So the real part is 0, is equal to 0, and the rule also said that x squared plus y squared has to equal the imaginary part, which in this part is 2. So from this we can get an equation that says, okay, this cancels, 2x squared is equal to 2, x squared is 1, so x is equal to plus or minus 1. Alright, and if we, let's say, put 1 here, okay, let's put plus or minus 1 in x squared plus y squared equals to, let's just put that there. Let's put the plus or minus 1. When you square, you get 1. So y squared is equal to 1. So y is also equal to plus or minus 1. So theoretically, we're getting 4 possible combinations. Let me just write the 4 combinations in red. 1 comma 1, 1 comma minus 1, minus 1 comma 1, and minus 1 comma minus 1. But we can't test all 4 possibilities. We cannot. So we need to find a way to eliminate them. And now the rule had a third part that said 2xy equals the imaginary part equals 2. So xy is equal to 1. Simplifying. So the product of our numbers have to be positive. So either you will need to have a positive or a negative. So this cancels and this cancels. So we get that x equals 1 or that makes no difference whatsoever. So x comma y either equal 1 comma 1 or minus 1 comma minus 1. And from this we can finally get our w, for instance, which is the square root of delta. Alright, let's move on now. So now we get that, and just to make it clear, if we use 1 plus I or 1 minus I, it makes absolutely no difference. I'm not going to be showing you that it doesn't make any difference. You guys just need to know that it's very easily done. You can just try out both and get the exact same answer. So let's just find it. So w is equal to, let's use 1 plus I because it's simpler. And now the quadratic formula says the solution is z is equal to minus b, and b was 2i in this case, so minus b, which is minus 2i, plus or minus the square root of delta, which in this case we found to be 1 plus I, over 2a, which is 2. Solving for that, we get that z1 and z2 equal. So minus 2i plus 1, okay, so it's half 2i plus I minus half I, and here we get minus half, so minus 3 over 2i. So our two solutions are minus half minus 3 over 2i and half minus half I. So I'll just recap over what we did. First, we found delta to be b squared minus 4ac 2i, but now we have to get the square root of delta, and we cannot easily get the square root of 2i. So we need to assume there exists a complex number w, which is x plus yi, such that w squared is delta, or w is this radical delta. If you square both sides, you get w squared equals delta. So we get this, and using the rules in the book, we can easily get that x squared minus y squared is the real part and x squared plus y squared is the imaginary part. From that you get 4 possible combinations as highlighted in the circle here, and using the condition that 2 times the product of x times y is the imaginary part again, we can shorten or cut it down into the 2 possibilities, minus 1 minus I or 1 plus I, and then is just a straightforward usage of the quadratic formula to get the roots. Give you guys a few seconds and then let's move on to number 6. Alright, let's see number 6. Solve z to the power of 4 plus 81 is 0. Z to the power of 4 plus 81 equals 0. I'll give you guys a few seconds and let's check. So basically it is number 6. Z to the power 4 is equal to minus 81. Alright, so now we have to say obviously that z is a complex number where it is x plus yi, right? But how, we need to convert this negative 81 also into a complex number. So we have to say that, okay, what's the magnitude of negative 81? Isn't this basically negative 81 plus 0i? So I can just do negative 81 squared plus 0 squared and take the square root and thus get that the magnitude is 81 cis. And let's find the argument. The argument is 0 over minus 81. So tan inverse of 0 is 0. But, and this is very important, my a is negative. So I add a pi. So it is cis pi. So z to the 4 is 81 cis pi. This is a very familiar equation. Well, to find z, don't we have to take the 4th root? So isn't z the 4th root of 81 cis pi? It very much is. So what we do is, when you take the 4th root, we have to do 81 the 4th root. We have to take the 4th root of 81, which is 3 cis. Now what you're supposed to do is pi plus 2k pi over 4. Now basically you have to add 2k pi to the thing inside. Let's call this theta. So it's theta plus 2k pi over n, where n is the root you're taking. Now when we're taking 4 roots, we start from k. Now k is the integer values. It belongs to a set of integers where k is 0, 1, 2, 3. Because we start from k equals 0 and then we keep going 1 up. So easy way to figure out is k has to be 1 less than n. N is 4, k is 3. N is 5, k is 4. But it has to be 4 values. So 0, 1, 2, 3. So now we have to find z0, z1, z2, z3, where the number represents the value k takes. So I'll let you guys copy up till here and then let's continue. Okay. So z we had said is 3 cis pi plus 2k pi over 4, where k is 0, 1, 2, 3. Now let's find z0, z1, z2, z3. And those are our 4 roots. Let's put a big box so that we can show this is our answer. Alright, z0. So it is 3 into. Now I'm not gonna be writing from cis. I expect you guys to automatically write okay cosine plus I sine and then simplify. I'm just gonna write cis of the angle and then I expect you to find the answer. I'm gonna put the final answer and you guys should know how to find that. 3 cis. Alright, now if we put 0 here, 2k pi becomes 0, so it's 3 cis pi over 4, which very simply is 3 radical 2 over 2 plus 3 radical 2 over 2i. So that's z0. z1, it is again 3, 3, 3, cis, cis, cis. We put the 1 in place of k. So it is pi plus 2 pi, 3 pi. So it is now 3 pi over 4. When simplified, we should get again 3 radical 2 over 2 plus 3 radical 2 over 2i. Substituting k equals 2. 2k pi is now 4 pi. 4 pi plus pi, 5 pi, 5 pi over 4. And now again when you simplify this, you should get negative 3 radical 2 over 2 minus 3 radical 2 over 2i. and I have made a mistake here. I forgot to put the minus sign here, because cosine of cosine of 3 pi over 4 is minus 3 radical 2 over 2. My mistake. Alright, I am sure. Yeah, okay. Now substituting 3 into 2k pi makes it 6 pi plus pi 7 pi, 7 pi over 4, which gives us 3 radical 2, that's not rightly placed, over 2 minus 3 radical 2 over 2i. And these are the solutions to the equation z power 4 plus 81 equals 0. So what you're supposed to do in a nutshell is basically get an equation for the 81, because z power 4 equals minus 81 in terms of x plus yi, or in terms of modulus cis the argument which we got here. Take the fourth root of that, which is the fourth root of the modulus cis the argument plus 2k pi over n, where n is the number of roots you're taking. So 3 cis pi plus 2k pi over 4, and then k is obviously 4 values because we're taking 4 roots from 0 till 3. Then we keep substituting in each in the equation with each value of k, and then we keep solving, and this is how you get the 4 roots. Alright, now we'll move on to the core grid, and I'll hand it over to Rohan.
Core grid number 1, which of the following Argand diagrams could be the locus? And you basically have arguments z minus I is equal to 60 degrees. Now if you want to do this quickly in your, what you call it, multiple choice or written or computer correctable, all you do is it's 60 degrees with the x-axis or with this point, so then you have this, you draw a 60 degree angle, and then it says z minus I, so since it's minus I, you do the opposite, you make it go up, because now you need more I to get to the 0 mark, if you get it what I mean. So this shifts up 1 I unit, and that is the graph. So that's one, there's the same graph basically, it's just the scale is different. The roots of the complex number where b and c are real numbers and z is a complex number are 2 minus I and 2 plus I. What is the value of c? Well, the written way to do this, I should have done the written way as well for this, which is z minus I, so x plus y I minus I, so that's equal to y minus 1 over x is equal to, what's tangent 60? Tan 60. Put that in your calculator and you get the mark. So tan 60 x plus 1 is equal to y. That's the straight line if you see the value y equals mx plus b. Now to number 1. Number 2. 2 minus I is the root, so z minus 2 minus I. And the other root is z plus, or is it z minus 2 plus I. Now if you expand that, there is a whole something going on, so z squared, you do this here, then that again here, that again here. So let's just take the minus in and out, so minus 2i, and then this becomes minus I, minus 2. So z squared minus 2z, and then minus I z, and then you take this 2 here, so minus 2 z plus 4 and plus 2i. You get what I mean. So you do the same for all the terms, and then they should end up cancelling. The i's should cancel, so you do it z squared here, then I here, and all the terms with the I, with all the z terms, just singular z, and then the I should cancel and you should get a real number, and then here the same real number, and then whatever you get here for the real number is what's c. What's the modulus of the root of the equation? Here you solve for z, So you move minus 11i to the other side, then divide by 1 plus I. So how that works is minus 7 plus 6i, so plus 11i. So minus 7 plus 17i over 1 plus I, and then multiply by the conjugate, 1 minus I, 1 minus I. And then this becomes 1 minus I squared, and I squared is minus 1, so 1 plus 1, so it becomes 2. And then minus 7 into 1, so minus 7 plus 7i, and then plus 17i minus 17i squared, which is plus 17. Then 17 minus 7 is 10. Plus 7i plus 17i is plus 24i over 2, and that is equal to 5 plus 7i. And you're left with 5 and 7. Oh, sorry, 5 plus 12i. And then calculator, square root of 5 squared plus 12 squared is 13. So the modulus is 13. Number 4. Given that a plus I and b plus I are two roots of the equation, what's the value of a plus b? So this is a quadratic equation with imaginary. So you just use the formula where minus b plus or minus square root of discriminant over 2a. So let's just apply it. Over 2a, so a is 1, see. And then minus b, so minus b is just 5 plus 2i. And then plus or minus square root of b squared, so 5 plus 2i squared. So 5 plus 2i squared is 25 plus 2 times 5 times 2i, so plus 20i plus b squared, which is 2i, the whole thing squared, so 4i squared. I squared is minus 1, so minus 4. Then you have minus 4ac. A is 1, like I said before, and then c is 5 plus 5i. So let's get all the x and y's together. 25 minus 4, so 21, and 21 minus 4 times 5. So that is equal to square root of 1. So 25 minus 4 times 5, which is minus 20. So 21 minus 20 is 1. Then we have 20i minus 4 times 5i, so minus 20i. So we're just square root of 1, which is very simple. So then it's 5 plus or minus 1, and then plus 2i over 2. So 2i over 2, it's plus I. Then 5 plus 1 will be 6 over 2 is 3 plus I. Then 5 minus 1 is 4 divided by 2, that's 2. So 2 plus I. So the two values of a and b are 3 and 2, so 3 plus 2 is 5. Number 5. The list below includes all the roots of z cubed minus 8. Select all the roots. So obviously the closest one, z cubed is equal to 8, is 2. So that's one of them. But then you have other hidden roots or imaginary roots. So z cubed equals 8, so z is equal to 8 into 1 over 3. Now 8 can be written also as, for imaginary form, 8 into cosine 0 plus I sine 0. Now multiplying it by 1 over 3 means it is now 8 power of 1 over 3, which is 2, into cosine 0 over 3 plus 2 over 3 pi. So cosine 2 over 3 pi plus I sine 2 over 3 pi. Now 2 over 3 pi is 120, so cosine is minus half, and then sine 2 over 3 pi is sine 120, which is root 3 over 2 I. Now times 2, so minus 1 plus root 3i. So 3 is one of them and 1 is one of them. Next one, you just have to skip ahead, or not skip ahead. This one, k was 1. Now let k equal 2. So cosine is 4, sine is 4. 4 pi over 3, it's 180 plus 60 degrees, so quadrant 3. So 60 degrees, so cosine is now going to be half. So still minus, sorry. And this now ends up being negative. So minus 1 minus root 3. So 6. Next one, 6. Which of the following is true about the locus of points which represents the complex number? Okay, this one. Here, just some intuition, you'll probably have like 2 circles, or that with variable radii, but the intersection is always going to be along that axis, or along a certain axis, where it will be the perpendicular bisector of the centers. So from that intuition, we know it's 3, 2, because the minus is flipped, one of them, and the other one is plus I, so it will be minus in this case, so 0, minus 1. So that's 4 and perpendicular bisector, so straight line. But how you do it mathematically is z is equal to, I'll use x plus yi, or x, it's equal to x plus yi. So this means that x minus 3 squared plus y minus 2 squared is equal to x squared into y plus 1 squared. So x squared minus 6x plus 9 plus y squared minus 4y plus 4 is equal to x squared. So let's just cancel x squared here, and then y squared, so let's cancel y squared here, is equal to 2y plus 1. So let's simplify this. We get 6y is equal to, move 1 to the other side, so plus 3. 9 plus 3 is 12. 12 minus 6x plus, now divide by 6, so y is equal to minus x plus 2. This is the equation of a straight line, and it's the perpendicular bisector of A and B. Number 7, determine the locus of points which represent the complex number z in an Argand diagram. Okay, so this, you have to combine this into one. So z is x plus y I, multiply it by the conjugate, x minus y I, and then above is x minus, or x plus 1 plus y minus 7 I. Now this whole thing into x minus y I. Yep, you can see it's going to be long. So this factors into x squared minus y squared I squared, and y squared is minus 1, so plus y squared, into x squared plus x minus xy. So what I'm doing is multiplying this, into plus or minus y x plus 1 I. Now the next one is this one into this one, plus x y minus 7 I, and then the last term, which will be I squared, so it becomes negative, so that becomes positive, so y into y minus 7. So let's put all the terms without an I to one side. So x squared plus x minus xy plus y squared minus 7y and plus I. So then you have this one here and that one here that's left with the I. So it becomes xy minus xy and minus y minus 7x. Okay. Now what you do after this long simplification, after the long simplification, is you're left with this term, this updated term. So then argument of that is simply minus y minus 7x over this term here, as in the imaginary part over the real part. Now the x squared plus y squared should cancel, so you're left with minus 7x minus y over x squared plus x plus y squared minus 7y is equal to tangent pi over 4, which is 1. Now move this to that side. You should end up with minus 7x minus y is equal to x squared plus x plus y squared minus 7y. Simplify it. X squared plus 8x plus y squared minus 6x equals 0. And now you know how to simplify it into the equation of a circle. You'll end up with x plus 4 or x plus 8 divided by 2, that's 4, so x plus 4 squared, and then minus 4 squared, which is 16, plus y, do the same thing, you have a minus 6 divided by 2 is 3, so y minus 3, the whole thing squared, you're left with minus 9 equals 0. So minus 16 minus 9 is minus 25, put it to the other side, is equal to 25. They said if it's a circle, give the radius, so 25 is 5 squared, so the radius is 5. Number 8, the locus of the point P that satisfies z minus 6 is equal to 3z minus 2. Now, z is x plus yi. So for each, let's simplify it and get the modulus. Modulus is square root, so square root of x minus 6 squared plus y squared is equal to 3 into square root of x minus 2 squared plus y squared. Now if we square the whole equation to get rid of the radicals, is x minus 6 squared plus y squared is equal to 9 into x minus 2 squared plus 9y squared distributed. Now start cancelling. So you are given x minus 6 squared, which is x squared minus 12x plus 36, and then the y squared and the y squared, they cancel, so you don't have to worry about that. Oh, actually they don't cancel, you have the 9, my bad. So it becomes 8y squared, and the x minus 2, or the 9x minus 2, is 9x squared, and then minus 4x times 9 minus 36x, and then plus 4 plus 36 plus 8y squared. So you start cancelling. So move x squared, you get 8x squared, move minus 12x, minus 24x, plus 36 and plus 36, they cancel, and then you're left with 8y squared. plus equals 0. Now divide by 8, x squared minus 3x plus y squared. Now you want to get the equation of a circle. So over here, you divide by 2, so minus 3 divided by 2 is 3 over 2. Now square that, it's plus 9 over 4 minus 9 over 4. You're left with x minus 3 over 2 squared plus y squared is equal to 9 over 4. You move this to the other side. But what is 9 over 4? It's 3 over 2 squared. So when they ask for radius is k over 2, k is equal to 3. Number 9. 3i is the root of this equation. Here's the trick. If you have a real number, or if you have an equation where all of these coefficients are real numbers, so 1, minus 4, 9 and minus 36, then you have an imaginary root. So if you have an imaginary root, then the conjugate is also a root. So 3i, so minus 3i is also a root. So x plus or minus 3i for this is a root, and x minus 3i is also root, so x plus 3i. So this whole expression is a root, where it's x squared. So x squared, or actually it's just the difference of 2, so it's x squared, and then minus 9i squared, and I squared is minus 1, so x squared plus 9. So that is a root. Now to get the real root, you do x squared plus 9 long division. So first is x, and then x becomes x cubed and 9x. Now minus, these two cancel out. You're left with minus 4x squared, so minus 4, you get minus 4x squared minus 36. Now minus that, these two cancel out. X minus 4 is a root, so x minus 4 equals 0, so x equals 0, x equals 4 equals 0. See? So that's just factoring. On to number 10. Has one positive root. What is the value of the root? Given that, 3i again. So this means that x squared plus 9 is a root, because you know these are all real numbers. So the conjugate was a root, you do that form, and you should get it. X squared plus 9. So x squared, because x power 4 divided by x squared. So x power 4, this cancels out, 9x squared. Subtract it. You get minus 7 minus 9 minus 16x squared. Now minus 6x cubed, so minus 6x. So this cancels out, but then this becomes minus 6, so minus 54x. And that's a subtraction, so this becomes positive, so this cancels out. So you're left with minus 144. Now again, minus 16x squared divided by x squared is minus 16. And sure enough, you see that it cancels out. So minus 144, this is subtraction, this cancels out. So x squared minus 6x minus 16 is a root. So let me just rewrite that. Minus 16 is a root. Now, use calculators, you use minus b plus or minus square root of discriminant over 2a, or you use directly the function, which is 1 minus 6 and minus 16. You get 8 and minus 2. Now they said has one positive root. Positive root, so 8. Now minus 2, because minus 2 is negative. And that's pretty much it for chapter